Good afternoon, everyone. I know you can't really communicate with me with the headphones on. I don't really want to wear these either, to be honest, right now. But I'm assuming you can all hear me right, yeah? Cool, great, thank you. So, thank you very much for coming to listen to Client Side Encryption. Today, what I'll hopefully do is take you through, a good understanding of why it's useful and why we've built it into the product. It's obviously very much in the philosophy of MongoDB as a whole. Has anyone got any issues with sound, by the way? It's too loud, is it? There's a rocker switch underneath that you can control the volume with. So MongoDB's philosophy, as you know, most of the developers out here today, is very much about reducing the pain for you. My name's Matthew Aylard, obviously. I'm a pen tester, and security is a passion for me, but not everybody else. And security can be quite a complex subject to implement. So what Mongo's tried to do here is literally, with a lot of pain of development over the last 2 years, there have been 18 developers completely dedicated to this. You'll probably remember from the keynote speech, last year MongoDB spent 400 million on resource and development. And a large chunk of that was to develop this feature within MongoDB. And I'll go into the reasons why, obviously, and hopefully, if we've got time at the end, I'll give you a bit of a demonstration on actually how to leverage that feature from the Mongo shell. So yeah, 18 developers for 2 years. As you can imagine, that's quite a bit of work. And the reason for that is because the drivers that you interact with MongoDB with fundamentally need to have a better understanding of how to talk query language-wise, because we're not obviously having to pass that data to MongoDB's engine before it retrieves that information. So what I would like to explain here is that we've made this, I guess, very trivial for you. So in terms of a demonstration, and this is kind of a bit of a joke, but I'm just getting across how trivial this should be for you. So this is me inserting a record into a collection within MongoDB using client-side field-level encryption. Okay, nothing strange for you out there. Does anyone disagree with the code up there at the minute? Okay. Step 2, I'm going to read that document back from the collection in MongoDB into a variable called collection, or doc. And then I'm going to display that to standard out, print doc. And what do we expect to see? The document we inserted, okay? And that's the whole point. This is all client-side encryption. It's taken the pain away for you. You haven't had to, I guess, work with complexities of which ciphers to use, the best way to implement it, etc. So that's the end of the demo. Bit of a joke, I know, but we're going to go into a much more detailed demo, of course. So what does we see this? Obviously, the engine eventually receives from the client the encrypted data within that key pair value. And obviously, when we receive it, we do the driver receives that back from MongoDB's engine, and of course, the driver then decrypts that information and represents that back in plain text for us. So security is not a new thing to MongoDB. I'm sure most of you out there who've implemented or utilized Atlas are very familiar with the encryption storage engine, so encryption at rest, and obviously TLS. So security has always been a fundamental key component of MongoDB's success by storing your data in a secure, private, encrypted way. So if we look at this from an attack perspective, if I didn't enable any security whatsoever, where would my risks be with obtaining data from within MongoDB? So I guess during as an attacker, if I didn't enable authentication, for example, I could literally query the database and pull back whatever information I wanted, right? So obviously, I would suggest you enable auth. Agreed? And that's going to take that attack vector away. There is a little bit more of a complex way attacker might see the data. If they were snooping the network, for example, they could potentially see the queries and the results coming back over plain text over the wire. So obviously enable TLS, and that stops that attack vector. We also have the opportunity for an attacker to sit as a man-in-the-middle attack. So in other words, I'm pretending to be the MongoDB server, you're talking to me, and I can see what you're wanting to do. And obviously, TLS also mitigates against that because we're using a CA to validate who the person is we're talking to. Agreed? Okay. The next attack vector that we can mitigate against, obviously, is an attacker hitting the disk. They've managed to get hold of the volume. So again, enable encrypted storage engine. But what if we've got a DBA who's a little bit malicious or dubious, and that person has obviously got access to the data? And this is where client-side encryption comes in, okay? So we know that the DBA could essentially, with full access rights, look at any collection, pull any data out they want. However, with client-side encryption, we're going to be able to protect against that risk with the fields that are really sensitive data. So if we put that in perspective of boundaries, what do those technologies do for us in terms of mitigating those boundaries? So shrinking the boundary of plain text is what I'm talking about here. So with encryption storage engine, we know we're shrinking the boundary already. With TLS, we've restricted the boundary to the server and the client. With client-side encryption, we're really reducing that boundary. And again, please acknowledge, I'm not saying that client-side encryption is a complete replacement of any other sort of encryption. This is to work very harmoniously with your really sensitive data. So by shrinking the boundary it causes, if MongoDB doesn't, there are some obviously difficulties if you're encrypting the data in the database, right? So the fact that, if the database engine itself doesn't know what's in the field because it isn't plain text, it kind of adds some extra levels of complexity. And an update or replace that completely overwrites the value is still a risk, if you like. And also doing things like aggregation, where we're trying to sort of put two fields together. So in this example here, I'm doing an aggregate. I'm doing a project. I'm creating a name SSN, and I'm trying to concatenate those two values together. And clearly, because the database engine doesn't see those two values, that isn't going to be possible for it to do. So you need to be mindful when using client-side encryption that obviously you're doing this in an appropriate way that isn't going to affect your approach. However, what is interesting is that we've implemented two types of encryption, and I'll go into those a little bit more detail later. We've done random encryption and also deterministic encryption. So the cool thing about encrypting our data using a deterministic algorithm is that obviously if we store the same plain text, although it's cipher in the database, it will be the same cipher. So I'm able to obviously do a query to the engine, and it knows that if it sees this same ciphertext, it's going to be the same actual text value. Okay, so the database can still do those rich queries against the data and pull that back for you. So obviously you'll see the actual values. Okay, so there are two reasons when I'm talking to customers in the field that this becomes quite an exciting evolution of the product. The first one, of course, is around the fact that I'm talking to financial sectors, customers, etc., where they obviously have a commitment with us to know that all of these mechanisms are in place. But if we're going to be honest, these are promises, okay? How can they be completely reassured that their data is going to be secure? So by putting private data in the cloud, I'm going to use the analogy of a storage locker. Okay, so although we trust the vendor that's giving us this storage locker, we'll call this person Doris. Doris is obviously a great company to work with. We fully trust her, and I'm going to put my things into the locker, my secret diary that I don't want anybody else to see. And all those promises make me feel warm and fuzzy. But obviously Doris has the potential situation of the police maybe saying that we want, we've got some suspicious activity going on here, we want to be able to get to that data. And obviously Doris, although she's got the master key to everybody's locker, would by law have to give someone access to that. So what we're essentially talking about here with client-side encryption is the ability for you to still store things in the locker, but in your own vault that only you have the key to. And obviously by vault, what I mean is a field within the document. So if you put that vault in the storage locker, you traded off a little overhead for extra security, but since you're the only one who has the key, you're rest assured that you're the only person who's going to be able to get to that data. The risk, of course, is that Doris could still be malicious. She could remove the vault, she could take it out of the locker, she could burn the vault, and essentially you'd be replaced with a different vault. But the benefit, of course, is that ultimately she still can't read it. So you know that your data's safe. Yeah? The second reason is under the GDPR directive, the right to be forgotten. So obviously that's quite a challenge for customers that we talk to, and this would be a great way by using field level encryption to be able to say that it's easy to prove that if you delete the key, that we know that data for sure is not recoverable, even from the backups. So by restoring a database that's got encrypted fields that only you've got the key to, clearly you're saying, I've deleted the key, nobody else can get to that data. So it kind of delivers in that respect. So let's talk a little bit about, we understand the purpose of it now. Let's talk a little bit around how do we actually implement that within MongoDB. So what we've done is in the driver, added some additional Mongo client parameters called auto encryption ops. And again, please, I'm not preaching in terms of wanting to say you should encrypt all the fields or an entire document using this mechanism. There's still going to be pieces of information within the document that you want to keep, like in this example here, in my locker, with the same analogy, I've got my basketball, my chair, my plant, but the two fields that are really precious to me are in separate vaults. Now I can decide obviously to have a key per field, or I can have a key that unlocks all of those fields within the database as well. So let's, for example, in this one, I may want to encrypt the SSN with one key, and I might want to encrypt the credit card information with a different key because I want to give different people different types of access to the fields within that document. Now, obviously, to implement this, there are several steps, so I'm going to go through those steps now. The first thing we need to do is set a JSON schema. Are there any people in the room today who've implemented JSON schema within MongoDB? Yeah? I see a few hands. Cool. So what you were familiar with JSON schema previously was something that you would essentially pass server-side, and the server would make sure that if that particular structure of document was adhered to. So maybe we're saying that certain fields we would want, in this example here, I'm saying that A has to be an integer, and the maximum value of that integer would be 10, and in the value of B would have to be a string. Now, obviously, if I put A is 5 and B is high, that would be acceptable to the server-side JSON schema. But if I tried to insert 11 and false, MongoDB would reject the insert request. Okay? So this is what JSON schema is about. What we've done is added an additional property within that JSON schema now, but it also lives client-side. So the ability to essentially on client-side determine what encryption mechanisms you want to use, what keys, and on what fields. So, for example, we have within the encrypt, we have to specify a key ID or string, the algorithm that we want to use, which I'll go into obviously as well, and the BSON type, which identifies the type of underlying data so that Mongo's engine still knows how to treat that. But on the client-side schema, again, this is the reason that we still suggest that you put it on the server side, of course, is that that's kind of for the fallback for the mistakes. So if you've got a malicious DBA, clearly having just the schema on the server side would mean that they could alter that schema and essentially say that these fields aren't encrypted, so the encryption wouldn't be in place. So really, it's still on the server side as a reference to stop accidental hits, but it won't stop against the attack vector. So that's why it's important to have this schema now on the client side as well. Maybe I should have used those slides to explain that bit as well. So the server lies about the schema, and obviously that would be okay, so we've got around that. So we've defined the first part of this now, which is the schema map. So that's our first sub-option. Now let's move on to the next one. So jumping back to our analogy, as you can add more vaults to your storage for these different fields, you can appreciate that having lots of different keys is going to start becoming difficult to manage, okay? So again, those of you in the audience who are probably kind of thinking, well, okay, I've got these keys here, how do I actually then secure those keys? Because if I'm still storing those in Mongo, how's this going to go down? So we have this concept of having a master key vault, if you like. So the key vault becomes another collection within MongoDB. And within that key vault, that's where you have the key to that yourself. Now, I'll go into a little bit more detail about the types of different keys you can use and where you can configure those, but essentially, they are encrypting the other keys, okay? So without your master key, there's no way to decrypt those other keys to use those for the purposes of the client-side field encryption. So that obviously adds an extra step to our process where we have to define the key vault collection. So this is the next parameter. So we've got key vault namespace db.keyvault in my example here. So that's our second step. And obviously we've still got the same issue here. If an attacker drops the key vault collection, takes that key vault away from your locker, then what's the situation we're in now? Yeah, there's no way, it's irretrievable data. We cannot get to our data back. So we've lost those keys if somebody stole that key. So the next, obviously, process around that, which would make sense, would be to have that key vault not in the same key locker that vendor has access to, right? So that's where the next side comes in. You can actually specify that this collection that stores all of those keys in a separate MongoDB instance, whether it's on-prem with you, whether it's in another cloud provider or wherever else. So it kind of separates those responsibilities out. But obviously you need to specify where they are. So that's our third step. Step 4, we need to configure the KMS. So configuring the external service that encrypts our keys. The KMS obviously ensures that only we have access to those underlying key material of the keys in the key vault collection. So the crux of it is essentially that now my client can only be the person, or the thing, if you like, that's able to access with KMS those fields that you specified in the JSON schema as the data that it can decrypt. So let's just recap on what that process is. So here, I'm inserting a document into my collection. Doris again, we like Doris, and a social security number. Has anyone seen that social security number before, by the way? No? A few slides ago, yeah. Google it afterwards. There is a bit of a famous thing around that one. But anyway, okay, so first of all, the client, the driver, will have to validate against the schema. We're then going to have to get the encrypted key. We're then going to use the KMS service to decrypt that key, and then use that key to encrypt the field, and then obviously send that to the MongoDB database. All make sense so far? Yep? Cool? Okay. So let's go a little bit into the fine print now. So there are two encryption modes based on the same algorithm, okay, as I talked about before. So the algorithm is named authenticated encryption with associated data using advanced encryption 256 with cipher blockchaining and hash-based. I won't go on. Obviously, we, in the JSON schema, have to specify it in a smaller version of that, but it's still quite chunky, okay? But obviously, you can appreciate using these ciphers and these mechanisms that we're still providing confidentiality and also integrity. So you cannot kind of use these without authenticating to get that key, etc. So in combination with all of those mechanisms, we're in a good place. The next stage, of course, is then that you need to specify whether you want to use deterministic or random. Now, what do you think we'd use random for? Something like, low cardinality. So maybe I've got a field that stores male, female. That wouldn't be a good idea to use deterministic encryption because it would be pretty easy for someone who's trying to decrypt the data that there's only two different values. So in that case, it would probably be a good idea to make it less obvious to what field you're storing, right? So as an example, this is random encryption. So this is seeded with a random IV within the same mechanism. And this means that if I'm storing the same social security number using random encryption, and again, it would still show as different ciphertext in the document. Whereas with deterministic, of course, we're actually using a combination of the private key with the field value name, etc. And the SSN is then stored in the same ciphertext. So that means, obviously, as I said earlier, you can get to that same query within Mongo. The next field is stored exactly the same. So again, that means deterministic can be queried. So we can do finds against just normal SSN. Obviously, it passes the driver sends the encrypted format, the bin data, over to MongoDB, and MongoDB goes ahead and looks for those encrypted fields again. Now, there is another caveat here. Obviously, there's many different types that you can store key pair values with. And we are only going to support with deterministic because of obviously the mathematical complications here, the binary comparable types. So for example, in this situation here, I could return 1, I could return the long version of 1, I could also return a double, which means clearly that text with actually in the database is going to be different. So the ciphertext is going to be different. So obviously we block that. It's explicitly denied. Okay. So this is the ciphertext that's stored in a Bison binary type. So we've defined this new binary subtype called 6. And it's not only a new binary type, but also the old drivers will still work with it. So if you've still got old clients out there with 3.6 drivers, they're not going to balk, they're not going to crash, they're not going to fall over, but they'll still see it only as a black box. But clearly you'll need the 4.2 engine and driver to be able to sort of really understand what's behind those. So what do we use within the ciphertext even? So we've got the byte itself, which is an algorithm. We've got the byte key ID. We've also got a byte used for the original Bison type. Then we've got the payload itself. So notice that the key ID is an algorithm that also describes how to get there. And it also provides extra server-side validation as well. So it prohibits values, obviously, with min key, max key again, because again, it wouldn't make sense to encrypt those, and also importantly, Boolean as well. So obviously you've got true and false, it wouldn't make sense. And the payload includes the IV, the HMAC, and obviously this can add 66 to 82 bytes of overhead, so be aware of that, especially if you're storing something like an int32, it is going to increase the size of those collections. And what just to give you an idea of what's inside the keys as well. So we've got the UUID, which is how we identify the key when we're referring to it. So we've got the key alt names as well, so you can give it a name. This is how you'd associate it necessarily to the customer. And the key material, and some obviously of the metadata. And again, it's important to acknowledge that these keys are only decrypted and stored in memory. At no point are they on disk. So, taking all that into aside, let's look at an example here. So, in terms of a risk. So Doris has obviously heard our talk. She's got very excited, or he has, and decided to make an app called Mongo Diary. And within Mongo Diary, there are obviously several components of the website, and she's going to take advantage of MongoDB Client Side Encryption with KMS. Now, this site becomes extremely popular. And obviously, she knows she's storing sensitive information. People are treating this like their secret diary. And because of that popularity and Doris's awareness of Mongo technology, she decides to regionalize and shard MongoDB. And as she makes data local to her consumers of the app, one of her shards is stored in immoral authority dictator land. I think you can guess where I'm going with this. So, for whatever reason, immoral authority dictator land decides that they're not happy with some of the data that might be stored in this, and they seize the data center and obviously get hold of the disks. And obviously, they may have been able to read the encryption keys for the disk. But unfortunately, because they don't have the client-side encryption KMS key, they're not able to understand what's actually in those really sensitive fields. So Doris obviously explains publicly that, although I was a little bit nervous at first, don't worry about it, because all of that data is definitely encrypted to the point where nobody can get to that information. All agreed? Yep. And that kind of really summarizes what client-side encryption is all about. And if you're using personally sensitive, highly sensitive data, then obviously highly encourage you to look at enabling this feature. And as you can see, it's very simple to implement. So hopefully now I'm going to give you a demonstration of what that actually looks like. Yeah? Okay, so let's start with a terminal session. I just want to make sure, have I got Mongo running still? Yeah, great, okay. Is that clear on the screen up there at the minute? Super. Okay, so what I've got here is some code that I've essentially built into JavaScript, my schema. So as you can see, all the things that we talked about, I've specified deterministic key here. I've said that I want to use key 1 for that, key 1 for that field, and for the contact, I've decided to use a different key. And essentially, I build a collection and start to create the keys that I want to refer to, and then I start inserting data. So what I'm going to do in Mongo Shell is just import that JavaScript file and leave the shell open. So you know when you practice this 30 times and then I'm in the wrong folder, thank you. Schoolboy error. This is where my resilience kicks in. I'm not going to give in. Thank you. Okie dokie. That's a little bit better, isn't it? Sorry about that, guys. Right, okay, so I'm still in the Mongo shell. So if we do some show databases, obviously this session that I've now fired off and connected to, with my socket that's still open in the Mongo shell, it is now obviously being given all the parameters it needs to know where my key value store is, what keys I want to use. It's got the schema built into it, etc. So it knows when I'm inserting or removing or querying the data, which fields are expected to have. Now you'll notice that I've created, you could call this whatever you want, and obviously this collection at the minute is where it is, but I've called it __ key store just because I think that's a bit of good practice. It means it isn't a normal collection. and I'd also have to kind of review that again if I was thinking about dropping that key store. If I now go into DB people and do a find, let's say, and let's pretty that up a little, you can see that I'm able to see the data that I installed or inserted in plain text. And just to show that I'm not using smoke and mirrors here, if I go into the Mongo shell in a different terminal session, so a different TCP socket, I can still see those databases here. So if I use demo FLE and show the collections again, why is it that typing in the presentation is always harder? Okay, now you can see the bin6 format, right? So again, this is simply because although I'm connecting to the same collection, it doesn't know where to get the keys from to do any of the decryption. And also, because this is a demo and I'm obviously this is like kind of in dev mode, I'm using a local encryption key for my master wrapping key. I'm not using KMS. As you can see, my typing's bad enough, and if I was trying to connect to the cloud for a KMS as well, I probably would have gone even more wrong. The other thing I'd like to show you within that is, if we go back to the other shell, and I'm just going to insert, I'm going to insert another document here. You can see how that will look straight away. So let's, I don't know, change it to first name Mary with 3 M's. Okay, and then if I go back to my find query again, we should be able to see that, you can see that that's been inserted in plain, we can see that in plain text there. And if I go back to my other one, obviously they're all encrypted. And let's just jump quickly into Compass as well. So I'm just going to connect again to my local machine using Compass. Who uses Compass here? Yeah, everyone? That's great to see. A new piece of information. Compass is obviously heavily developed as well now. And obviously it in the latest version can understand this schema mapping as well of obviously encrypted fields. So if I go into that demo FLE, open up the people collection, again, although it has an awareness of those fields, you can see that because it doesn't have the ability to understand that encryption, it shows them as stars. And although I could edit, say, the city, there's no way it's going to let me edit the fields related to the encrypted fields. Okay, so that kind of makes sense, and also I think it's useful to see that if we go across to validation, it'd be nice if I could get to validation. So in Compass, this is where you can, view. For those of you who haven't used a JSON schema to define the structure of your documents in the collection, this is where you can clearly see what I uploaded from the Mongo shell as well. So this is again where I'm enforcing the schema on the server side to inserting my documents. Yeah, all make sense? Okay, great. So really, that's all I've got to show you today. I hope you enjoyed that presentation. And obviously, I'll open the floor up to some questions. Hopefully, I've got a runner there. So if you do want to ask a question, I'll hit you with the hand, and then we'll bring round a microphone for you. And also, while I'm doing that, I'm just going to put up the feedback slide as well, if you wouldn't mind.
So yes, if you can just stick your arms up loud and proud if you have a question. With about 5 minutes for questions. So first one over there, thank you.
Hi.
Hi, thank you for the talk. Can you show a longer example of how to set up the encryption keys? What are the different methodologies? You said that there's passwords, KMS. If you have a slightly longer slide with this, will be nice just to understand the encryption method there.
Sure. So I'm going to be over the booth over there, and we can, if you want to come and see me, we can run through those. Thank you. This gentleman over here, I think, is the close. Oh, got a sorry.
Run, son.
I'll see if I can keep you fit.
Run.
Is Ken in the audience as well? No? Okay. Hi, Ken, at the back. Sorry.
You mentioned, so it's full text encryption, fantastic. And also Doris's example that people are writing their entries and it's all being stored encrypted, so obviously if it's seized, no one can read it. But if someone wanted to search their entries using a text search that you can put as an index on your collections, does that now negate the ability for you to use full text search now, if you encrypt it?
Yeah, great question. And I should have covered this off, so apologies. So by those two methods of encryption that we can use with deterministic and random, clearly if you do choose deterministic for high cardinality, low frequency data, and just stepping back a little bit, I want to make sure that we understand that if I wanted to really be as secure as possible, then random would be the right way to go, of course, because that makes it even harder beyond all of those other constraints. But by using deterministic encryption on those fields, you can build indexes on them, because essentially, although they're not the value that you read them as a human, they're still comparable, right? So it can still search them. Sorry. Is there anyone on this side of the room first? No? Okay, great, thank you.
Hi.
Hey.
Great feature. How do you handle key rotation?
Key rotation, great. Okay, so as we talked about with KMS, you can specify your own key rotation on, so for example in AWS world, where you're specifying your AMS. So you create your IPAM account, and you're going to set the policies around that key. So essentially, if your wrapping master key is changed, we're still going to have the old one and the new one, but ultimately as it goes through the keys, it will change it for the new one. And the great thing of that, of course, is that the keys that are actually encrypting those fields don't then need to go and be changed, if you like, and go and encrypt the entire database again.
Yeah, so it means that we have to do an iteration and update them because we rotated the key, correct?
Correct.
Okay, good.
Yeah, but only the one key, only the one master key, which obviously makes that overhead, zero, essentially.
Any other questions? Son, I'm sorry.
One question that we do get often, by the way, while we're going to get to this one that I'll just cover off in case it's in somebody's mind. If anyone's got concerns whether this is an enterprise feature or community feature, in terms of community, all of those functions are available and usable, but you have to specify the use of them. The advantage of using the enterprise version is that it's all automated. So there is a Mongo decrypt D kind of process that runs that kind of goes off and gets those keys automatically for you rather than you having to specify which keys to use all of the time. So it just takes that overhead off even more.
Thank you. Are there any tools to encrypt or add encryption to fields that are not encrypted right now, or maybe remove encryption from encrypted fields once you decide you no longer want to encrypt them?
That's a really good question. I've not had that one. I think you would probably have to approach that by creating. I'm almost reluctant to say this because I'm sure somebody in the audience will say there's an easier way. But my initial thoughts are that you'd have to have document versioning almost, and you would have to kind of remove that into another field that you would know that as a strategic strategy that you'd gone ahead to want to do, you'd be moving that data out of one field into another. So, but it'll probably be, I'm not 100% confident on that one, so I think if you want to come and grab me offline, there's some other colleagues of mine who do the dev of this who will probably be able to suggest some other ways as well.
Thank you.
Cool, thank you. Well, thank you everyone for listening.
Hang on a second, Matt. One more.
Sorry.
One more question, dude.
One more question.
One more.
Okay.
Yeah, we've got time for one more, yeah.
Yes, thank you. My question would be, what's the performance impact on encrypting these fields?
Yes, so client-side encryption is client-side. So the benefit here, of course, is that the only overhead you're going to add to the situation really is on the client side. So you're not actually essentially putting a load additionally on the server. It's all being done where the drivers are interacting with the database. So very, very little performance overhead concerns, which is, again is one of the beauties of this technology.
Thank you.
Thank you.